Expedition is a full enterprise suite of tools providing companies with a comprehensive set of standard and unique tools that allows designers to create complex designs with ease and the highest quality in the least amount of time. Let's take a quick look at an actual customer's challenges and how they were solved using concurrent design and collaboration. The following Tier 1 automotive companies started seeing requirements with higher complexity and smaller footprint devices from their customers. As such, their current design process started creating bottlenecks that were impacting schedules. After implementing Expedition concurrent design processes and collaboration, their design teams were able to reduce cycle times by up to 50%. Expedition supports concurrency throughout the design process. This includes schematic entry, design rule entry, and layout. Let's start with schematic. Here we see two engineers with the same project open. The engineer on the left opened a page in the project first. When the engineer on the right opens the same page, it opens as read-only, indicated by the message at the top of the page. If an engineer is the first to open a page in the project, they become the owner. When a second engineer opens the same page in the same project, they will only have viewing capability. However, if this second engineer opens a different page, not already opened by someone else, they will become the owner and are free to make edits. The engineer on the left will now start to capture a new page by adding an HDMI interface. Using Designer's intelligent search capability, the engineer on the left finds the components he would like to add. One of the components being added will be duplicated. By simply using Control-Drag, the engineer can replicate this device. Notice the engineer on the right can instantly see the new additions by the engineer on the left. Next, we will use multi-net connection functionality to add nets. This allows the user to add multiple connections very quickly between two components. First, the from connections are selected. You can see a number is automatically added to each pin based on how they are selected. Next, the to connections are selected. Again, notice how they are automatically numbered and net lines are added between the two components with like numbers. The newly added nets are visible by the engineer on the right, viewing the same page that the engineer on the left is currently editing. Now we need to add net names to the differential pairs we just added. Using Designer's Add Properties tool, the engineer can add multiple net names very quickly. We will now move on to concurrent constraint management. You will notice as each engineer opens the constraint editor, each will see the exact same rules, nets, and component information. With Expedition concurrency, a constraint is only locked while under edit. The engineer on the right will now use auto-assigned differential pairs to create the newly added TX differential pairs. This is quickly accomplished because they all have the plus and minus suffixes. Next, we will create a new net class for these differential pairs. Notice that even though the engineer on the right created the differential pairs, the engineer on the left is going to create the new net class. The engineer on the right will see the new class created and a lock symbol next to it, letting them know they do not have editing capability until the engineer on the right is done. Once done, the engineer on the right can change the name of the class, locking it for the engineer on the left. Now complete, the engineer on the right can add the new diff pairs. We now need to add constraints to the new diff pair class. Notice when each engineer edits a cell, the other can see it's locked. As we move our cursor over the top of the edited cell or being edited cell, we can see who made the last edit or who is currently performing an edit. Moving on to some examples of concurrent layout, also known as Team PCB. In Team PCB, each user has their own user handle, allowing each designer to have their own custom environment. This allows the user to create their own customization, which is more native to their design practice. Team PCB force field displays a cone of influence, highlighting where each designer is working. In this example, 3 users are working on the same design concurrently. Notice that as 2 users on the left start working on placing planning groups, the user on the right can clearly see what those users are doing. Again, this is Team PCB's cone of influence functionality conveyed to each user while each is working on their section of the design. The user on the right now switches to 3D view. Notice that as the users on the left start placing their planning groups or individual components in 2D, the user on the right instantly sees those components placed in 3D. The user on the right will now create a 3D clearance rule specific to U1405. As the designer on the right starts to move parts in 3D, two items should be noted. First, the online DRC clearly conveys a clearance violation as the part is moved close to U1405. Second, the component being moved is in the same area as the designer working in the lower left. As such, component movement is clearly conveyed to the user in real time. At this point, the two users on the left are ready to start performing sketch planning. Sketch planning allows the designer to define where a group of nets will be routed and the layers that will be routed on. In this example, they are defining the paths for the data nets from the DDR memory to the processor, alternating between layers 3 and 5. Again, as the users on the left are working, their cone of influence is clearly visible to the user on the right. Next, the user on the right will use SketchRoute to quickly route the data nets. As before, when the nets are routed by the user on the left, they will immediately be displayed to the user on the right. Some of the nets were not completed during sketch routing. The sketch router's highest priority is quality. It will not add a connection if there's no room. As such, both designers will use HugRouter to push and shove routes to complete the open net. So far you've seen a very unique technology, true concurrent design, provided by Expedition Design Flow for schematic capture, rule entry, and PCB layout. Now let's move on to another form of collaboration which allows the PCB designer and mechanical engineer to share design content. Typical PCB outline and mechanical interfacing components are defined by mechanical engineer. During our demo, we'll be using NX from Siemens and Expedition, following a design flow used by best-in-class companies. Here you can see the mechanical engineer has created the board outline and placed critical components. Opening the PCB Navigator, we can see all the objects that can be passed to layout. Components with refdes, part number, mounting holes, board outline, special shapes. Now let's generate baseline data to be sent over to Expedition. We'll be using IDX 3.0 data format. After exporting has been completed, you can validate data being passed by reviewing the information dialog box. From Expedition, while in the 3D view, we can open NCAD Collaboration Utility. This interface allows the PCB designer to review data coming from mechanical before committing to the design. After selecting the baseline object from the file selection area, you are presented with all the objects that will be created or placed in the PCB. For further assistance with reviewing content, you can select an item and see more details. With Highlight active, you can make this object appear in the design for graphical preview. Once we apply the collaboration content, your design will be updated with all the objects you've chosen to import. The synchronization state will be updated and show you're ready to send and receive a new proposal or baseline. Changes are tracked so the history of what has happened can be seen whether you're the original engineer or someone new joins the project. Notice that one of our components is using the 2.5D model instead of a 3D. This is due to the fact that the component does not currently have a 3D model association. Expedition provides advanced model alignment capabilities to make this process painless. After you've found a model available publicly or created one yourself, we'll import the model into the design. Notice the model shows green arrows above the part. These are used to rotate the part to face the proper direction. Next, we can define a seating plane where the 3D model will sit on the PCB. For this connector, it will be the bottom of the plastic case. For other parts like ICs, you would choose the bottom of the pin. Next, we notice the pins are not aligned with the holes. We will use the Pin to Center command to automatically align the pins. We now have our model fully aligned. Jumping ahead to a completely placed board, let's review quickly some of the other capabilities we can take advantage of in the 3D environment. Using display control, you can set the 3D and 2D views to drive each other. When tiling the windows side by side, you can move a part in 2D and see it move in 3D, showing any X, Y, or Z height DRC violations in real time. Vice versa, you can move items in 3D and see them move in 2D. Additionally, there's a plethora of visibility controls to turn items on and off in the 3D view. Now let's exchange component placement we've completed with the mechanical design team. Notice we are informed the PCB contains data that's different from the original baseline we started with. Knowing this, the collaboration state is set to proposal. When in this state, only design objects that have been added, moved, or deleted will be shown. Also note that if appropriate, at any point you can send a new baseline which contains everything. Like before, when importing data, you can select an item and see details about that object. An item can also be deselected if you choose not to have it included in the export. Lastly, when working with NX, we can export all the 3D model information we've placed in our PCB with the IDX output. A mechanical engineer can now import this proposal. From the Proposed Changes dialog box, you can review all the content being proposed. In this case, we only want to accept and import new component data. Once completed, this will automatically create a response file which is required to complete the loop. When we go back to Expedition, we will see there's a response file available for review. When selecting this file, we can see all the additions were accepted and we can complete the proposal so we're ready for future changes. Now let's show a quick example of an incremental change in accept and reject process. We will move the USB and board-to-board connector for approval by the mechanical engineering team. As noted previously, when selecting a design object in a proposal or baseline, with the highlight switch turned on, we can see where the item is being added, changed, or moved to. Lastly, we can add a comment to any object documenting the design intent. In the mechanical domain, the designer can review comments and view changes visually, much like we can in Expedition. The mechanical designer has decided the USB change is not acceptable. This change will be rejected with comments added as to why. The board-to-board, on the other hand, is connected via a cable, making its new location acceptable. Once the review process is complete, a response is created. Back over to the PCB, with the response selected, we can see the USB connector movement has been rejected and why. We will accept this response, completing the handshake process. We are now ready for another change process if needed. When planning an aggressive project development cycle or your customers are demanding shorter development times, design concurrency and collaboration are the answer. With Expedition Enterprise, your team will have all the tools required to develop a high-quality product in less time.